Hey guys, so I just wanted to run through quickly a couple of things that I would have explained in person, but not being there, I thought I'd just make this video instead. So basically this task, you'll get this booklet today from Mr. Hall. You'll have 2 weeks to complete this booklet. This booklet's only on vectors. And then 2 weeks today, so the last week of school on the Monday, you'll hand this back in to me, and you'll also sit an in-class validation. The validation is on proof by induction, okay? And it'll be handwritten, not an online validation, so I'll be hand marking them and collecting them after you do them. So what that means is you need to be studying your proof by induction as well as completing this. So the in-class validation is not on vectors, it's only on proof by induction. And this take-home part is only on vectors, okay? So, in terms of this take-home part, a couple of things I want to go through. So basically, it's a problem where there's some mosquitoes in a classroom with Miss Murray. Now, take the time and really read through this carefully so you understand everything. The first thing you have to do, though, is to make everybody's investigation different, and that way nobody copies each other, nobody has the same answers, is you're actually picking the initial positions of the mosquitoes. Miss Murray, M, that's me, the vector M. I have a vector that is the same for everyone, but what you have to do is write in column form the vector's initial positions. The mosquito's initial positions. Okay, and you're going to put them on this grid. Now, a couple of things. The initial positions obviously then need to fit on this grid. Miss Murray's position does. And then you create vectors in regards to them, and you calculate things in regards to them. And then eventually you'll start doing arithmetic in regards to them and then drawing them. So my advice is not to pick massive vectors, okay? Pick smaller vectors around close to the origin or close to the axis, because so that when you do have to draw, say, like 2a minus b, that vector will still fit on the grid. Now, worst case scenario, I'll also upload this Word document onto our Compass page. You can erase that grid and put your own grid there, okay, if your vectors go over it, okay? So don't stress too much about it, but I just thought I'd make a note. Don't pick really big initial positions. Try and pick smaller numbers and make it easy for you as well. Don't pick ugly numbers. Because yes, you answer a lot of questions about in regards to those initial positions all the way down. So you'll see here that there are 4 parts, okay, and the last questions were a bit tougher, a bit more wordy questions. Okay, so that's all I really wanted to say about it. All right, take your time with it. You can print out another one when I post it on Compass. Use this one as a draft if you like. It's weighing 25% of your ATAR mark, so, put a lot of effort into it. And there was one more thing I was going to say. I can't remember, but that's okay. Anyway, if you have any questions, just email me.